In this video, I will talk about small o notation. In the previous video, we saw that what is big O notation. Big O notation, that topic has been discussed in the previous video. Now, what is small o notation? One thing we should understand first. In calculus, we write f of x is equal to x. But when we talk about computer science, in computer science, this x is replaced with n. So these are integers, and these functions measures the efficiency of algorithm. Since in computer science we talk about the algorithm. So small o notation is a strict criteria. When we say that some function is big O, order of n, then it means that the growth of algorithm at most is at most n. So it means that it can have actually value of n. But when we talk about small o notation, when we have small o notation, it means that that function grows strictly, it grows strictly lower than n. Now you must be thinking, what does that mean? We will talk about those functions which are uh, this function is slower than the other function. How can we write that some function f of n, which in terms of computer science, we have written this in terms of computer science, f of n is order of n. Let me just go back to big O notation first. We say that some function is order of g of x. It means that it can be equal to that function. Its growth is equal to that function, but it can uh, never crosses the range of that function. So it means that f of x is less than or equal to some constants, and then we have g of x, and since we are interested only in the positive value, so we put mod over here for some x greater than k. So this was the definition of big O. It just says that it can stays the same sometime, but after x is greater than k, then it can have greater g of x is bigger than f of x. Now when we say that some function f of n, which depends on n, is order of n, small o notation, so it means that limit n approaches to infinity, then that function is far less than this n, order of n. So it means that when we take a limit, this value is far less than n. It means that if it is less than n and it is greater than, it is actually n, then the answer will be equal to 0. Then we get answer 0. You can see that, for example, if we have 1 over n, this becomes limit n approaches to infinity, so this is 0. When we have limit n approaches to infinity n under root over n, for example, then we have 0. So that function is far less than n. If it says that if your algorithm is f of n order, is order of n, then it means that this function is slower than order of n, and the algorithm is very good. If it depends which order you are talking about. Remember that here can be two, here can be we have three, here we can have, for example, if I say that f of n is order of log of n, then it means that this function that you are talking about, unknown function, is always less than this log of n, and this algorithm will be a very efficient algorithm. So let me just give you some particular function, example of some particular function over here. Suppose we have f of n is equal to n under root, and it is order of small o, order of n. It means that limit n approaches to infinity, n under root divided by n. This gives us 0. This approaches to 0 as n approaches to infinity. Similarly, when we have f of n is equal to log of n, we say that f of n is equal to log of n is order of n. Remember that I emphasize over here, small o notation does not say that you should have n always in your calculation or in your algorithm. It can be anything as well. So if it is log of n, then when we take a limit n approaches to infinity, log of n divided by n. So log of n is smaller than n. If you just plot that, you will see that since it is slower, so it is equal to 0. Finally, let me just give you a comparison what the small o notation will look like. We are talking about some particular example of n. Suppose we have n over here. This function is f of n. All the other functions that we discussed, one is n under root, it will be very small like this. And then we have log of n. Log of n will also be some lower value than n. So these are strictly lower than n. So that's the definition of small o notation. Thank you for watching.